Hello and welcome to Radisys TotaleNodeB Handover demonstration. Today we are going to demonstrate S1 based handover using Radisys TotaleNodeB solution from femtocell to femtocell. Before we start, let us understand the handover procedure and why it is required. In LTE or any other wireless technology where the user equipment is mobile, the handovers are required to maintain the call continuity and to enable the user to access network services from cells of his own network or from a different network. The Radisys TotaleNodeB solution supports this feature and allows up to 16 UE to simultaneously hand over from one eNodeB to another eNodeB. The handover can be triggered either by a measurement report sent by the UE or by a network decision such as service provision or network load coordination. The neighboring cell radio conditions or the RSRP are measured periodically or event based by the UE. The handover trigger parameters such as hysteresis, time to trigger are configured at the eNodeB. When the triggering conditions are satisfied, the UE sends a measurement report to the eNodeB. The eNodeB performs the handover decision and replies with a handover command. This initiates the handover procedure. This is how a typical handover setup looks like. We require at least two eNodeBs connected to an EPC via a LAN router and a user equipment which is mobile. Let us have a look at the call flow for the S1 based handover. The first trigger is from the UE side, which is initially connected to the source eNodeB. It sends out a measurement report based on the trigger. The source eNodeB performs the handover decision based on the measurement report and sends the handover required command to the MME. The MME replies back. The MME forwards the handover request command to the target eNodeB, which performs the radio resource allocation and admission control. The target eNodeB then sends the handover request acknowledgement to the MME. At this point, the MME sends the create indirect data forwarding tunnel request to the SGW to create the tunnel for indirect data forwarding. The SGW replies back with create indirect data forwarding tunnel response. The MME then forwards the handover command to the source eNodeB, which builds and sends the RRC connection ring configuration together with the mobility info to the UE. At this point, the source eNodeB sends the status transfer message to the MME, which forwards the status transfer to the target eNodeB. The source eNodeB also starts forwarding the data on the indirect data forwarding tunnel created to the SGW. The SGW forwards the data to the source eNodeB via the same tunnel. The UE at this point will detach from the old cell and sync to the new cell by sending out the RACH request by the RACH procedure. After successfully completing the RACH procedure, the eNodeB the UE sends RRC connection reconfiguration complete to the target eNodeB and starts receiving the downlink data and sending the uplink data. The target eNodeB shall forward the uplink data to the SGW. The target eNodeB shall forward the uplink data to the SGW. It shall also send the handover notification to the MME. The MME will then send the modify bearer request to the SGW. The MME will send the modify bearer request to the SGW, which will reply back with a modify bearer response. After this, the SGW will send the end marker to the source inode B, indicating end of data transmission. The SGW will send end marker to the source inode B, indicating end of data transmission to the old tunnel. The SGW will continue forwarding downlink data to the UE via the target inode B. The MME will indicate to the source inode B to release the UE context by sending UE context release command, and it shall also delete the previous the indirect data tunnel created by the SGW by sending the delete indirect data forwarding request. Now we shall proceed to the actual demonstration of the S1 based handover. So hi, this is the setup in which we are going to demonstrate the handover feature. So this setup I'll explain to you a bit about the setup. We have two inode Bs, both are on Broadcom chipset on FDD band 7. We are using a Samsung S3 mobile to test the handover. This on the left is the target inode B, there is the source inode B. The source inode B cell ID is 25, the target inode B cell ID is 27. So we are going to move the UE, which is already attached to the source inode B, to the target inode B, and we are going to see a change in cell ID. So right now, as you can see, the UE is attached to source inode B and is streaming video. You can see the cell ID is 25, which is on the source inode B. So we are now going to slowly move this UE from source inode B to target inode B coverage. As you can see now, the physical cell ID has changed to 26, reflecting a successful handover to the target inode B. This you can also verify from the Wireshark logs, which capture the S1 based handover messages between the source and the target inode B and the MME. And as you can see, the UE is still seamlessly streaming the video, indicating a seamless handover. So this completes a successful intra-frequency S1 handover. For any queries and other demonstrations, please visit www.radisys.com. Thank you.